In this tutorial we're going to be going through colour theory, and we're going to be going through some basics, some technical, some science, and then we're going to end up with the probably the most important part for the course is colour meaning. But it's good to have some understanding of some of the technical before you go into it, and it really helps when you're actually working with lights and the camera. So when we first introduced colour at the very start of the course, covered it in design elements, we mentioned the fact that colour is made up of value, chroma and hue, or value, saturation and hue. So the value is how light or dark a colour is. The chroma or saturation is how intense a colour is, or how dull a colour is, kind of how much black's in it, how much white's in it. And then in hue is what we normally, when we talk about colour, that's actually what we normally talk about, is the hue of a colour. What's the name of that colour, whether it's red, blue, green, that's the hue. Relating to light when it comes to either a warm light or a cold light, this will become more relevant when we start talking about, in practical sessions, when we start talking about lighting a scene, where the light's coming from, or what lights we want to place in a situation. And this relates to warm usually means there's more red in it, and cool usually means there's more blue in it. And so when you're choosing a light for a situation, you need to be aware of whether it's a warm light or a cold light. So typically a light bulb will be generally warm, and that relates to, you know, if you're going to have light bulbs in your house, you generally want some kind of more of a warmish light to make it feel more comfortable. That's not to say all light bulbs are warm. In a workshop, for example, you're going to want quite cold light. You want to, you know, kind of a more bright, even white light to nearing to the blue spectrum, so you can see clearly everything that's going on. And this will make more sense when we understand exactly how light works. So some references here. Light bulbs, you know, we'll find light bulbs in more warm. Sunlight will kind of be sitting in the middle, slightly more warm, slightly more red to it. And then LCD. Oh, and sorry, the sunlight will change as the day goes on. You know, sunlight towards the end of the day will be more warm. There'll be more reds in it. But at the height of you know, midday, you're going to find it to be more in the middle. LCD screens, you know, your phones, TVs, you're going to find there's going to be, or can be, slightly more blue in that as well. So something to bear in mind when it comes to practically lighting a scene, and you need to kind of balance what kind of lighting you need depending on what you want to achieve from that. So some basic science relating to light about refraction and reflection. So there's two concepts here. So the refraction talks about how we can split the white light into its multiple colours. So white light is made up of many wavelengths of colours. This is probably something you may have covered in science. And so when you shine a white light through a prism, the prism will split those wavelengths into all its component wavelengths, and then therefore we can see all these different colours of white light. You see that again in nature when a rainbow occurs. The sun is shining through rain, and you see all the colours of that white light split into its many wavelengths, into its many colours. So that's refraction, that's the splitting of light. Reflection is actually more to do with how we see light. So when a white light is hitting me, as you can see right now, white light is hitting me, you can see, you know, I'm wearing kind of a light blue shirt. So there's a reasonable amount of blue in there. So the light is hitting this shirt, and the blue is generally being reflected back. So that's the reflection of light. So white light is hitting this shirt, and, you know, there's a reasonable amount of blue light reflecting back out from this shirt. Whereas all the other colours are more generally being absorbed into it. Now, in reality, there are some other colours in there. You know, there's some white in here as well. And when there's white, it's basically reflecting all colours back. But because it's mixed, you're seeing more of a, you know, you're just seeing the white. But because there's more blue in this, you're seeing more blue being reflected back. Now, if I move over to here, the projector is only projecting red light into the shirt. Now, what's happening now is you can't see the blue because there's no blue wavelengths hitting the shirt to be reflected back in the first place. All that's being reflected on this shirt is red. And the red wavelength, it's hitting what white there is, and that's being reflected back at you. Same goes for yellow. The yellow's hitting the white of this shirt, and then the yellow's being reflected back. So there's the some concepts of how you actually see light. You're seeing reflected colours, and that's exactly how the camera works as well. The camera is just capturing light. I say this repeatedly throughout the course. That's its primary purpose, is to just capture light over that period of time you press that button. How you compose that shot, how you set the settings in the camera, changes how that occurs. Okay, so a couple of things about additive and subtractive light. So when it comes to anything digital, whether it's on your phone, the computer, your camera, the projector, the TV, those use additive light. So what happens is we have this red, green and blue, and when we combine the reds, the greens and the blue, we create white light. And if you mix or merge any of those in different quantities, you get these different colours. If you just mix red and green, you get the yellow. So that's additive light. So anything digital, anything electronic, that's exactly how the colours are being created in that technology. When it comes to printing, it changes. We use a subtractive colour. And so what happens there is we mix CMYK, cyan, magenta and yellow, and when you mix those together you get black. Well, in reality you don't actually fully get black. What you get is a muddy brown, so they add the K, the key at the end. Basically the key means black. So they have cyan, magenta, yellow and black to create all the different colours when it comes to print. It's still, ultimately, when you look at that, it still all works the same. Light is being reflected back into your eye, and if white light is being reflected onto a blue colour on a page, all that's happening is the blue's being reflected back at you and the other colours are being absorbed, and that's why you see that particular shade of blue. So to open up to do a comparison between CMYK and RGB, and what the visible spectrum is, it's good to kind of look at this. Now it looks a little bit confusing, we'll take you through it bit by bit. But it's important to know the limitations of the technology you're using, the printing you may end up using, and what your eyes can see. So in this graph here, all the colours you can see are basically the visible spectrum. That is what you and I can see with our eyes. That's the possible visible spectrum. Now, this is not an accurate representation of that, because the technology we're using can't actually represent all the colours our eyes can see. We can see far more colours than the majority of technology out there can actually show us. Now, there's some very high-end monitors and some very high-end TVs that can get towards that colour space. But typically, your phone's not going to do this. So this is what we can see, but it's much richer than that. In the middle of all of this, there's some straight lines, and that represents a few things. Now we're going to pick up the Adobe RGB, the dotted orange line here. Now this dotted orange line is everything the Adobe RGB format can actually represent to us in the RGB color space. And so we can see that it can get towards the real high turquoisey, really rich, bright, greeny blue colours, but it doesn't quite get to where our visual perception can go. But it gets close to it. And then further down here, we get quite close to the kind of purples and the reds over there and the yellows over there. We've got quite a lot of those. So it does a reasonable representation of what we can see. Now, when it comes to printing, though, the basic CMYK can't represent certain colours. And so if you see with this this pink line here, you see that this corner here is truncated, and anything captured by this RGB colour space here is kind of cut off. And the same here, anything caught by this RGB colour space, the CMYK would cut off. So CMYK is not going to do very well with kind of really rich turquoise colours there. So there's something to bear in mind when it comes to actually printing something. Now, I don't ask you in this course to do the conversion between RGB and CMYK. which you can do. Photoshop does it very, very easily. But to do it, it's you know, it can be a little bit dangerous, because what you're doing is that you're actually cutting off certain colours. And that, you know, once you've cut those colours off, once you've done the conversion to CMYK, those colours from the RGB spectrum that were there are just gone, and you're not getting them back. So I don't ask you to do the conversion. That's an important thing. But you must be aware, you need to be aware that when it comes to actually printing, this matters, because if you're sending it out, so for example, if you're making a magazine, you're going to send it off to you know, maybe some really rich colours up there, you're going to send it off to print. And the CMYK can't show those, so it does a kind of compression of those colours. You know, it's not just cut off, it actually compresses it down, so you know, it adjusts it. The same way if you send one of your prints off to one of our in-house colour printers here, it does exactly the same. It kind of compresses the colour space, because all printers, or all the printers here, print in CMYK. We don't have any additional colours. And yet, sometimes we do, when we send out to print, we send to graphic shops that do art prints, and they have maybe 9 colours in their printers, and they can start reaching these kind of colours, these extremes of the RGB colour space that CMYK can't. So that's another reason why I don't ask you to change your RGB images, which all cameras capture, by the way. I don't ask you to change that to CMYK, because you may actually be losing colours that, if we do send out to print, you would lose if you'd done the conversion yourself. Okay, so now we're going to move to just some stuff you've probably covered in art before. So here we've got the colour wheel. Here we've got the primary colours. So we've got yellow, red and blue. Note, this is not RGB. It's a separate thing we're talking about here. We're talking about primary colours. And this is more about meaning. You know, when we're talking about RGB, we were talking about some technical stuff, whereas now we're talking about meaning. Now, at this point, this is the point where you might want to pause the video, because you're going to go back to you may be annotating some visual inspiration images or some of your own images, and you can talk about primary colours. So primary colours create a bold statement. You know, that's typically how you would talk about primary colours. They make a really bold statement. So if you're using really rich yellows and reds or blues, you can say, oh, this image is using primary colours to make something, to emphasise something, or it dominates something, or something like that. Then we've got the secondary colours. They're just the colours in between the primary colours. And then in between those, the primary and the secondary colours, we have tertiary colours. So that's just kind of background. Don't necessarily have to go into these for this course. But something you do or should use or should be able to recognise is complementary colours. So complementary colours are colours that are opposite each other in the colour wheel. Okay, so any colours that are opposite themselves in the colour wheel are complementary colours. And that's something good, something if you can recognise that, or certainly use in your designs, it means your image is going to be more aesthetically pleasing. And that's a key term you should always use with it throughout your portfolio, throughout your design discussions, is if you can make images aesthetically pleasing, they're going to be better to look at, they're going to communicate better, they're going to work well together better. So choosing text and using complementary colours for text and imagery, it's always a positive thing. If you need to find those complementary colours, because one of the things is really important when you're choosing colours is don't just randomly choose a colour. It's very easy to kind of pop open the colour palette within Photoshop, for example, and just go, oh, I quite like red, I'm going to use red. Well, that's a terrible reason to use red. You know, you're designing for an audience. Well, does red work well with that audience? For that particular topic, does that shade of red work well for that particular topic? The other thing is you're picking a red from, you know, a tiny little window, and you're kind of going, well, I'll have that red. Well, if you're using imagery that uses red and you just pick another random red, yeah, you think you're getting a red that's like it. You're not at all. You need to use the colour picker in Photoshop and select that red and actually see where that red sits within hue. Well, the hue is the red, but then the tone and also the saturation, because those two really matter as well. When you just pick a red, you're just picking the hue, and really you need to be considering the saturation and the tone at the same time. So using the colour picker Really, really strong suggestion there. Now you can go to color.adobe.com, the American spelling of color there. You can upload images and it will suggest color, certain color matches for that, and it may, there's lots more than just complementary colors. So you can look at those options and it will kind of guide you through what kind of colors you should use within your design. So that's a really good tool to use. So now this is the point where at this point you will definitely want to pause the video to discuss color meaning when you're doing your annotations, whether you're annotating other people's designs in visual research or whether you're annotating your own designs. This is crucial. There will be, every single time, you will be able to talk about color meaning within designs that you have in front of you. So whether you're aware of it or not, colours have meaning, and they may be obvious, and a lot of these can be subconscious as well, and a little bit subjective. And there's an element of cultural meaning to this as well. So let's take red, for example. So these in general are taken from a Western point of view, a culturally Western point of view. So we look at red, and I think most people agree with this. Red means love. Well, that's, most people would agree with that. Red means anger. So it can have these two meanings as well that seem to contradict each other. But again, I think we'd all agree that red can mean love and red can mean anger. Some of the other things you may not be aware of or might not have considered is red means sale. Now think back to how many sale signs you've seen. Now obviously not all sale signs are red, but think about the majority of sale signs in shops. A lot of them are red. And they've not just randomly picked that. There's meaning to that. It invokes an emotion, it invokes a reaction from people when they see that combination of the word sale and red. It's an urgency to go in and buy things. So while love and anger may be obvious colour meanings, red and sale may not be such an obvious colour meaning, but it definitely is there. Now, something in this list that, this refers to Western culture, but in China, for example, red has a completely different meaning, and that is luck, good fortune. And, that's not something we would necessarily link with the colour red, but in other cultures, and that's really important to note, if you're designing for a particular culture or you're looking at a design from another culture, that may occur because it has different meanings in different countries and different cultures. And so you go through this list, again, certain things. Yellow means cheer, fresh, childish, warmth. Black means bold, power, strength. Green is soothing, eco-friendly. How many signs do you see that use green? So BP, for example, BP petrol station, they use a lot of greens and yellows. Now BP are not, the most eco-friendly company, but because they've used those colours and the way they've used the pattern in their shape of their logo, this naturally creates more of an eco-friendly thought within people's minds, even though the reality is very, very different. So ultimately, this kind of thing is up to you. This is your personal perception. There's no absolute right or wrong. There's a lot of commonly agreed colours, but in general, you won't get this wrong. So you need to use this on a regular basis to identify meanings within advertisements and pictures, imagery. You need to use this